Alright, this is a new video on a new function which is called the hyperbola. And now we're going to investigate the parent graph, which has got the equation y is equals to a over x, right? So here I gave you a table of values and our a is equals to 1. So if you punch into the calculator, you've been given the x values, the negative from -2 to +2. These are the values that you get, right? When x is -2, you get a -half, -1, and so forth and so forth. And now when you go to a graph, this is how you would represent everything that was here on the table. This is how the graph looks like here, your x-axis and your y-axis. Now, there are certain things which are interesting on this parent graph. For example, if we come back to our table here, you find out that we've got x which is equals to 0. Now, if you go back to your algebra and you're working on fractions, what do we know? We know that the moment you make your denominator 0, what happens? You get an undefined. So meaning to say that here 1 over 0 is what? Is undefined. What are the implications of this undefined? Remember, here we say that when you're looking for your y-intercept, you let x equal to 0. But here in this instance, when it's as far as a hyperbola is concerned, the moment you get to x is equals to 0, now you're causing this particular equation that we have here to be undefined. So in other words, on this parent graph of a hyperbola, it means that there is no y-intercept. There is no y-intercept. Now, since there is no y-intercept, it introduces another thing as well. It means that if you look at the branches of this hyperbola in quadrant 1, as well as the branches in quadrant 3, these branches, the way I've drawn them is I've drawn them such that they get closer and closer to the y-axis, but they never touch the what? The y-axis. Whether you're in quadrant 1 or you're in quadrant number 3, these branches are not touching the y-axis. Now, what does that mean? Now we're introducing you to a new term which is called what? Which is called an asymptote. What is an asymptote? An asymptote is a horizontal or vertical line that a graph approaches but never touches. Meaning to say that our graph here is approaching this y-axis in quadrant 1 and quadrant 3, but it will never touch this y-axis. That's an asymptote. So in this particular case, if you check here on the notes, I said that we've got a vertical asymptote line and a horizontal asymptote line. Our vertical asymptote line is x is equals to 0. Why? Because observe here, if you come here, check, we're saying that here the graph also is not touching the x-axis, and this graph is also not touching the x-axis. But let's just verify. Remember, if I'm looking for the x-intercept, what do? The first thing that I do is I let y equal to 0. So let y equal to 0. So my equation is saying y is equals to 1 over x. And I'm going to let y equal to 0. So there we go. 0 is equal to 1 over x. Now to get rid of the denominator, I say multiplied by x, and I multiply by x. And this x cancels with that x, and x times 0 is equals to what? 0. Is 0 equal to 1? The answer is no. So if you write this, this is incorrect. But if you do this, 0 is not equal to 1. This sign means 0 is not equal to 1. So in other words, we don't have an x-intercept. And on the y-intercept, the calculation for you just to see it, besides me speaking about it, we would say that let x equal to 0. Our equation is y is equals to 1 over x. And we are now saying y is equals to 1 over 0. If I take a calculator to calculate this particular question, let's see what the calculator will tell us. So this is the calculator, and then I now say 1 divided by 0. There we go. And it says math error. But when we are writing, we don't write math error. In such a case, this is what we call undefined. And because we don't have an x-intercept or a y-intercept, now we are calling this x-axis that this is an asymptote and the y-axis is an asymptote. Now, there is a way that we represent asymptotes in most cases. This is when you now see in your textbooks, there will be a broken line because this is an asymptote. Now we are now indicating it here that, oh, okay, this is our asymptote. Our graph is never going to touch this. It can come close, but it can never be touched. And also here, our asymptote on the y-axis. And as you can see here on the y-axis, right? And this, those are the asymptotes that we have. I hope that everybody has understood this. These are the features of a parent graph. On the next graph, we're going to be exploring what? We're going to be exploring the effect of A on the graph. How are we going to be exploring that? We're going to be exploring that as the number which are found on A, when your A is more than what? When your A is more than 0, what happens to the parent graph? You don't want to miss out. And not only do we explore that, we also explore the fact that when your A is less than 0, what happens? Till we meet again, please do consider to subscribe, like, and comment.